Welcome to Math in Front of Me. Today we are going to do two questions, and the session A, evaluate the integral going from 0 to pi, ln of 1 minus a cosine x dx by using Feynman's technique, and let I of a is equal to the integral of this. And then the session B does evaluate the integral going from 0 to pi and the ln of 5 minus 4 cosine x dx. So let me just do the session A, but this time it's gonna be a kinda difficult. So let me just write down the original integral first, and then the I of a should do that, right? And then the Feynman had next to ask me to differentiate both sides which respect to a. So let me write this as I prime of a, which is, and then we are going to differentiate this. Differentiate ln of 1 minus a cosine x. First you get 1 divided by that first. And then multiply by the derivative of inside, right? 1 is a constant, and then on the top you pretty much just get, and then because we are differentiate this function in the a row, and then negative cosine x is just a constant, so let me just multiply by negative in front, and then on the top we get cos x. So you see that, right? So how can we do this though? On the top we have a cos x, and then here on the top we have a cos x. This kind of annoying, so let me just try to give it an a in front, but that will change the whole question. So don't forget to divide by a, which is multiplied by 1 over a here, and then I'm going to split it in two fractions, split by two fractions. So I'm going to minus 1 and then add 1 at the same time. So this one, a cosine x minus 1 divided by that, you can factor out the negative, which is negative 1 minus a cosine x divided by 1 minus a cosine x. This and this, they will cancel each other out, and then negative 1 times that, which is 1 over a, right? And then you get integrate 1 dx from 0 to pi, and then here negative 1 over a distribute inside, you get negative 1 over a times the integral of 1 minus 1 over 1 minus a cosine x dx. That will make the integral way simpler, you know. And then integrate this 1 dx from 0 to pi. Integrate really quick. Integrate this, you get x, and then plus pi. Evaluating from pi to 0 to pi, you get pi, right? And then you get pi over a here. So this one is kind of tough. 1 over 1 minus a cosine x. Whenever you see the formula like this, I would like to use the t substitution here. So the t substitution is let t is equal to tangent of x over 2, right? And then I'll call dt dx, our dx will be equal to 2 over 1 plus t squared dt. And then I cos x, and let me write down a sine x here. Sine x, I can tell you this is equal to 2t over 1 plus t squared, and then our cosine x is equal to 1 minus t squared over 1 plus t squared, and then our tangent x, just figure out by yourself. Just this divided by that, you will get the form of t, right? So dx is equal to that, so we can bring the 2 outside. You get negative 2 over a, and then put our lower limit, upper limit, plus 0 into it, you get 0, and then put pi into it, tangent of pi over 2, which is just equal to infinity. And then you're going to get 1 here, and then 1 minus a time, and then cos x, which is just equal to 1 minus t squared over 1 plus t squared, and then we are going to multiply by 1 over 1 plus t squared dt. So keep going, you get pi over a minus 2 over a times this integral 1 over, and then multiply by 1 plus t square inside, you get 1 plus t square. And then this 1 plus t square and 1 plus t square, they cancel each other out. So let me just multiply by negative a inside, you get negative a, and then multiply by inside, you get positive at square dt. So you are going to get pi over a minus 2 over a times this. Let me just factor out the t square and at square. You get parentheses 1 plus a times t square, and then plus 1 minus a dt. Because we are going to use the formula, so let me just write this thing as our square root of 1 plus a times t and the square. You get the original back. And this, let me write this as square root of 1 minus a square dt. Because we are going to use the formula, which is 1 over the integral of 1 over x squared plus a squared dx. This is equal to 1 over a times inverse tangent of x over a plus c, right? So you can do another substitution here, but let me just do it in my head, in your head. So you get negative 2 over a times the 1 over this. This is a constant in the table, you know. And then times inverse tangent of square root of 1 plus a times t divided by this constant. However, though, you are going to multiply by this 1 over square root of 1 plus a outside, because this inverse chain rule, you know, derivative, you need to use a chain rule. But we are going to multiply by 1 over square root of 1 plus a to cancel the chain rule, you know. Just do it you can do a substitution in your head. Let u is equal to the inside. So, and then we are going to evaluate thing from 0 to infinity. Remember to put it inside the t. So, here's the deal. You get pi over a and then minus 2 on the top, and then a time. So this time that you can simplify to square root of 1 minus a square, and then this one put infinity inside, you will get inverse tangent of infinity, which is pi over 2, and then put 0 over just 0, so far you get this, and then 2 and 2 they are cancelled, so you get this is equal to pi over a minus pi over a times square root of 1 minus a squared. So remember, this is equal to I prime of a. So we are going to integrate both sides. I of a is equal to pi times ln a. However, though, pi times ln a, does it mean we cannot put an a here? Does this mean a cannot be equal to 0? No. When you plus 0 into the original integral, you get integral of ln1, which is just 0. Integrate 0 from 0 to pi, which is just converges. So you are going to see what happened about this ln a later. So I'm going to do this here. Let me just integrate this. Factor out the negative pi here. And then we are going to integrate 1 over a times square root of 1 minus a squared in our a row. So to integrate this, I'm going to use our substitution. Let a is equal to sine theta, because you see the form 1 minus a squared. And then dA will be equal to cosine theta d theta. So this integral is really crazy, you know. So on the top you get cosine theta, and then a, which is sine theta, and then this is just 1 minus sine square theta. And then this is pretty much just cosine square theta, take a square root, pretty much just cancel each other out. This is cosine theta and cosine theta, they cancel each other out. And then you are going to integrate cosecant theta d theta. So remember, this is equal to negative ln of cosecant theta plus cotangent theta. So let me just put down a parenthesis here, because going from 0 to pi, the inside is always gonna be positive. So I'm not sure about the domain of A here. So, but I'm really sure that the integral of ln of 1 minus cos x going from 0 to pi, that integral converges. But when a is greater than 1.1, greater than 1, because the maximum value of cos x is 1, right? And then when a is greater than 1, and then for example 1.1 times that, you get just a negative number, right? 1 minus number that is greater than it, which is just diverges this integral. So we can show that a will be way smaller or equal to 1, but I'm not sure what is this. I can show 0, but I'm really sure the 0 can be equal to 0. The a can be equal to 0 here, because when you put 0 inside the a, that integral converges, you know. So you get this, but I'm going to change it into our a rho. So let me draw a triangle here, and then sine theta, which is just opposite over hypotenuse, and then this is just use the Pythagorean theorem, which is 1 minus a squared. So cosecant theta, which is this divided by that, which is 1 over a. And then cotangent theta, which is this divided by that. You need to be really careful here. When you do something wrong here, you just get the entire question wrong. So be really careful here. So we can combine, because they have the same denominator. I'm going to write this as this, and then ln of something divided by something, you can just write this as, in front we have a negative, ln of this, and then minus ln of this. In front we have a negative, so it becomes positive ln a, right? So it becomes negative pi times this. Don't forget to put down a plus c here, because this is an indefinite integral. So this one, pi times ln a minus pi times ln of 1 plus square root of 1 plus a squared plus ln a. I'm going to plus c here, because it's an indefinite integral here. Do the same thing, just integrate both sides, you get a constant c here. And then when you distribute the negative pi, you see negative pi, ln a, they cancel each other out, right? So ladies and gentlemen, you only get I of a will be equal to pi times ln of 1. This is a plus, right? It's pi times ln of 1 plus square root of 1 plus a squared. It should be negative. I think it should be a negative side. Wait a minute, because I'm really sure what happened here, because a can be equal to 1 here. When a is greater than 1, you get a divergence, right? Divergence integral. So we should have a negative sign here. So be sure you need to do it really careful. So minus a, and then plus c. So we are going to figure out what's the c here. So this is equal to that, right? Cosine x, and then let me just put a is equal to 0 here, And then you will get pi times ln of what? I do something wrong here, so please forgive me to make another video. So put 0 into it, you get pi times ln2, and then plus c, and this integral we already tell you this is just equal to 0 if you plus a is equal to 0 inside, which is equal to 0. So ladies and gentlemen, you are going to get c is equal to negative pi ln2. So you will get this integral ln of 1 minus a cos x dx, which is just equal to this thing, pi times ln of 1 plus square root of 1 minus a square, and then minus pi times ln2 here. And then let me just move on to section B. So we are going to evaluate the integral of ln 5 minus 4 cos x going from 0 to pi. So we're going to use the thing where whenever you see two sections questions that has a really high chance you need to use the thing on the section A, right? In the section A. So we need to get something like 1 minus some constant time cos x. So let me just try to factor out our 5 here. And then 1 minus what this as 4 over 5. They will that's 5 you cancel, you can get the same thing here. So we're going to use the product of the logarithm. You get ln5, right, times the integral of this integral of ln5 going from 0 to pi. So let me put down my ln5 outside the integral because it's a constant, and then plus the integral of ln of 1 minus 4 over 5 cos x dx going from 0 to pi. So this one is just pi times ln5. And what about this? This is just ln of 1 minus some constant times cos x going from 0 to pi. So we can use this formula. So this formula, which is just our plus pi times ln of 1 plus square root of 1 minus 4 over 5 square, and then minus a pi times ln2 here. So let me use our calculator here. Inside you get 1 minus parentheses 4 over 5 square, and then take a square root and then add 1. So this is just equal to a over 5. So let me put down as pi times ln of a over 5 minus pi ln2. We can simplify it more. So this is just pi times ln5 plus, here I'm going to use the quotations rule of the ln, right? So you get pi times ln a, and then be sure you need to multiply by pi here. So minus pi times ln5 and then minus pi times ln2. So pi ln5 and this pi ln5, they cancel each other out. We can, what this says, ln of 2 power of 3, right? So you can bring the 3 outside, so you can get 3 pi ln2 minus pi ln2. So ladies and gentlemen, your result is gonna be 2 pi times ln2. This is just really crazy, you know. Here I do something wrong. I get the inside is equal to 1 here. So you get the constant is equal to 0. So I do some trick here, you will get 3 pi ln2 and 2 pi ln2 and 3 pi ln2, they are really different. So be sure, you need to make sure this constant is really true, right? So be careful when you are doing a math question like this. So look at this. Because of the inverse chain rule, right? You are going to multiply by 1 over square root of 1 plus a here. If it does not have this, it will be just 1. This section is just 1. So our video, right? This is really long enough.